go through the various types of files available. Smooth file, flat hand bastard file, rasp cut file, flat dead smooth file, half round file, and triangular file. Flat bastard file. Size is 9 inch. Metal is high carbon steel, hardened and tempered. Used for rough metal cutting for high material rate removal. Now, smoothing file. The size is 9 inch. The material is same, high carbon steel, hardened and tempered. The use is shining, smoothing and finishing. File. You can see the grooves available. Size is 8 inch. Mat- Material is again same, high carbon steel, hardened and tempered. Now is rasp cut file. Size is 8 inch. Material is same, high carbon steel. It is used for soft metals, wood, aluminium and lead. Flat file. Size is 6 inch. High carbon steel, hardened and tempered. It is used for shining, polishing, etc. Half round file. Size is 6 inch. This is used for half round slot cutting. Material is again the same, high carbon steel, hardened and tempered. Now the square file. Size is 8 inch. Material is again the same, hardened and tempered. Used for square slot and square holes. It is used to make round holes square in shape. Now we come to round file. Size is 8 inch. Metal is high carbon steel, hardened and tempered. To file from inside the hole. To make the hole oval or circular for users such as those. Triangular file. Size is 6 inches. Material is again high carbon steel, hardened and tempered. It is used to make V slots and triangular holes. There are three types of scrapers: the flat scraper, half round scraper, and the triangular scraper. The material is again the same, high carbon steel, hardened and tempered for all three scrapers. For flat scraper, the cutting edge is corner. This corner is the cutting edge, as you can see. Okay. So in all the three scrapers, it is these corners. The use of flat scraper is to scrap the flat surfaces. It is used to bring about accuracy on flat surfaces. Half round and triangular scrapers are used to scrap inside the holes. The chisels now. First, the side cutting chisel. Second, we see the diamond point chisel. You can see the tip of these chisels. The half round chisel. The cross cutting chisel. the round chisel, and the flat chisel. Material is again the same, high carbon steel, hardened and tempered. Size of flat chisel is 6 inches. It is used to cut small rods, sheets, etc. Cutting angle of the flat chisel is 60 degrees. And see, the angle is 60 degrees. The round chisel. It is used to cut round grooves. The slot which we cut using this chisel has high depth and smaller diameter. Through holes are used to make from this chisel. Cross cutting chisel. These are used for square slot cutting. Half round chisel is used for half round slot cutting. The, the depth of the slot caused by this chisel is less and the diameter is high. And diamond point chisel. It is used for V slot cutting. Side chisel. It is used to remove excess metal from the surface. For example, after welding, after chipping, we can use this chisel to remove the excess material from the weld and then we can file it. It is used to level the materials. Reamers. This is the fixed reamer and this is the adjustable reamer. The material is high speed steel, hardened and tempered. The fixed reamer is used to remove the material from inside the hole. While drilling, the hole is created by scratching of the material, but this scratching causes the size of the hole to be uneven. So we use this fixed reamer or the adjustable reamer to smoothen out these holes and to bring it to the exact shape. Now the using of this adjustable tap handle and fixed tap. This has 6 slots and 6 blades. It has nuts on both the sides. If we loosen the back nut, it moves down, the blade shifts downwards, so its outer dia increases. And if we lose the upper nut, so the dia decreases. This is again for the same purpose, to ream inside the holes. Like for example, bushes are used in a lot of machines. Straight flute drill. The metal is high speed steel, taper shank drill. The angle of cutting, it's 118 degrees, 118 degrees. Metal is again the same, high speed steel, hardened and tempered. This is also called twist drill. This is a twist drill, which is a straight shank drill. The drill was referred to as taper shank drill because the shank of the drill, that is the lower part of the drill, is tapered, What happens is when we push it inside the drill machine, it has a taper slot in it, so it goes and fits in that drill slot. So the taper actually is provided so to fit the drill in the drill machine. You can see here the straight shank drill. This is a counter shank drill, counter bore drill key. See, you can see the opening of the drill slot here. We are rotating the key anti-clockwise and clockwise. Now closes. This is drill chuck. This is tap set. This is the tap set for internal threading. There are three pieces in one set for adjustable tap handle and fixed tap handle. This is these are the two tap handles. Taper, plug and botter. We'll show you how to make internal taps. This is a job that has to make internal taps in it. So we rotate one round complete forward and then half round back. So what happens is when whatever material gets cut in the first forward round rotation, it gets removed in the half reverse tap. So the tap does not get stopped. So we take out the first tap, put in the second tap. So this is the second tap at work. You can see we are moving one forward and half backward. The metal of these taps are high carbon steel, hardened and tempered. Last we will put in bottom tap, which finishes the threads. This is the bottom tap. The procedure is again the same, one forward rotation and half backward rotation. You can see we are moving forward then backward, forward again backward. You can see how on the job these taps are getting inside. These taps are penetrating inside the job. So this is the complete tap. We'll show you the side view of this tap. You can see the tap inside the job. This is the complete finished tap made by the three taps which we use. This is die handle. Die handle is used for making threads on the outside. And this is a die. The material is again the same, high carbon steel, hardened and tempered. We'll show you how to make external threads. So in this handle again the same procedure is followed as in internal threading. One forward rotation, a half backward rotation, one forward rotation and half backward rotation. Again and again the procedure is repeated. You can see how our tap is moving on the job and you can see the top of the job now. This is the complete job. You can see the complete job. This is a hand axle. Full name is adjustable hand axle. This is the frame of the axle which is tubular. These are the quarter pins and the fly nut. These are made of MS. This is the blade of the axle. The blade is of high carbon steel, hardened and tempered. To replace the blade, firstly loosen the fly nut Mm. Open the fly nut to make it loose. Mhm. We are opening the fly nut right now to make it loose. Now we have opened the fly nut. Then the blade becomes free. Remove the blade and replace it. Again, tighten the fly nut. While changing, remember that the angle of the teeth should be inclined towards the forward, because the cutting saws cut only when they are moving forward. They cut the metal only while moving forward, and while moving backward, they come free. And see the blade, and you will be able to see the angle on the blade. This is how a job is cut using hacksaw. The speed of moving the blade should be around 40 to 50 slides per minute. You should concentrate on the saw while moving the saw and move it exactly in the same vertical direction. There should not be any distraction. You should concentrate on the saw so that it doesn't get tilted. It doesn't get, if it gets tilted, the blade breaks immediately. This is the complete job cut correctly. You can see the blade broken, one of the examples of a blade broken because of tilted. Counter boring drill, counter sinking, counter shank screw and counter shank bolt. You see the flat head of the nut, counter shank nut, taper head. This is the taper head screw. Now our purpose is to level these heads with the surface. So this, for this purpose we use counter boring and counter shunking. This is called a pilot pin. This is a pilot pin. It is adjustable and threaded. It can be made for various sizes. This pin does not allow this hole to be eccentric. It prevents this hole from getting eccentric. It's the hole is done exactly in the center because of this hole. We give this depth equal to the length of this head. So it goes inside the surface and its head is at the same level at the surface. Counter shank is again the same thing. Its head is in taper. Counter shank drill. This is a normal drill. It's used for wooden. Only carpenters use this drill. This is the cutting angle of 90°. This is material is again high carbon steel, but it is not hardened. If we use a hardened drill, this leads to breaking of drill bit because the hardened drill are very brittle in nature. So we do not harden this. Another reason for not hardening these kinds of drills are that carpenters use these kinds of drills. They again need to resharpen and resharpen these kinds of drills because they are needed to use continuously. If a hardened drill is used, you need to go to a workshop to resharpen this drill. While if it is not hardened, a carpenter can do it himself in his workplace. This is angle plate. This is a scale. This is a universal marking gauge or universal scribing gauge. Fine adjustment screw. We loosen the scriber from this screw. The scriber is now free. Our aim is to mark a given position using this scriber, using this universal marking gauge. So we set it using a scale, a given height which is required. Now the height is being set for 4.5 centimeters using this universal marking gauge. This is a fine adjustment screw will be used, which we will use for small adjustments. If we loosen it, the scriber moves upwards. If we tighten it, the scriber moves downwards. We- Now we now we mark it. Now we need to be careful that a finished side should be kept at the bottom so that it is smooth, so that the marking is uniform. Again, we mark two sides that need to be cut. You can see the marking on the two edges that will be used to make a cut. This is the center punch. This is the number punch. Center punch metal is hardened, high carbon steel, hardened and tempered. This is knurling for gripping. The angle is 60 degree for dot punch. Center punch, the angle is 90 degree. Now, using the dot punch, we are marking the various positions on job along which we have to cut it. Now these makes the markings permanent along the contour in which we want to cut. You can see now the permanent markings that we have made using a dot punch. Now this is a letter punch. You can see all the letters on this letter punch. We are using this letter punch to mark names, numbers, any kind of text on the work jobs. This is a hollow punch. This is a bench vise. This is the body of the bench vise. This is a jaw. It is made of high speed steel. This is the handle of the bench vise. It consists of two parts. One is movable and one is immovable. Now if we rotate this handle, the one of the jaw moves and the other is kept stable. The jaw of this bench vise has teeth for gripping so that our job does not slip. Now we have to make it 45 millimeters square piece. First we'll file it to make the piece straight. So to check whether it is straight 90 degree, we use a tri-square. Now how to use a tri-square? Mm. We keep this surface attached to a tri-square, and in light we check if there is some surface free. Now we use a flat bastard file and we file using a flat bastard file. The hand should be straight, the hand should be stable, well poised hands, and we move it along the edge of the job. Uniformly they should be shifted side by side, and the file should be kept horizontal. The pressure should be applied when we are moving the file forward so that the file goes slowly and gets cutting, and while moving back the pressure should be removed a bit. We call it cross file. If you get a little angle so that one run in one throw the complete job is covered, now this is called a straight file. Drop file for shining. The file should never be used in a tilted position. The file should be balanced and should be straight. If we are moving it in a tilted direction, the job will also get tilted. We check it using a tri-square and check our 90-degree as shown in the video. Now we check it using vernier calipers what is the length of the job. Now since a lot of material has to be cut, first we'll remove some material using an axe saw. After cutting, a mark of 3 mm is made on the side and the face. This distance is used to make an angle of 45 degree by filing. This is showing how to use a file. So this is how a job will look like after filing. Now we have to drill a central hole in the job. So this is how to drill a job. First we hold the job in a benchwise and then we move the drill slowly downwards. You can see the drilling process occurring. Now we have drilled a through hole in this job. This is how the job will look like after drilling the hole, counter shanking and electroplating. The two parts using the screw, and that's how it's done.